Alright guys, so today we're going to write a quadratic function in vertex form given the following clues or information. We're given a vertex of -2, 11, a point of 0, 3, and an opening of down. So the very first thing I'm going to do is go ahead and just write out my vertex form. So the vertex form of a quadratic function is f of x equals a times x minus h squared plus k. And because it's vertex form, you can see the vertex right in it for h and k, and I was given that, so I'm going to go ahead and put those two together. So my vertex is, I'm going to label it, this is h and this is k. So I'm going to plug in the -2 for the h and the 11 for the k. So let's do that. So this f of x is just going to come down, equals a parentheses x minus, and then we're going to substitute in for the h here, this -2 in a second, squared, and then plus, and we're going to substitute in that 11 for the k. So in for the h goes this -2, and in for the k goes the 11. Alright, so now I'm just going to simplify this a little bit. So I get f of x equals a parentheses x minus a negative becomes a positive, so plus 2 squared plus 11. Okay, so now I need to find the a value, and I can only use what they've given me. So I have a point and the opening. Now the opening does say something towards the a value. It means that the a value needs to be negative when we finish, but I'm going to go to this point next. The point, I know for this one, is our ordered pairs always come in xy format, or x, in this case, f of x. So I'm going to plug in this 3 for my f of x and this 0 for my x. So here we have 3, and in for the x I'm going to plug in 0. So I get 3 equals, I still don't know what my a is, and then drop down this parentheses, plus 2 squared plus 11. Now I have an equation that's all numbers except for my variable a, and when it's all numbers just with one variable, you can go ahead and solve for this a value. So we're going to simplify first and then solve, and I'm going to start with the parentheses first. So here 0 plus 2 is 2, and then we're going to square it, plus 11, and then 2 squared is going to be 4. So instead of writing a times 4, I'm going to put 4 times a plus 11. And then if I go ahead and solve this, or start to solve this, I'm going to do the inverse, or the opposite of adding 11 to each side, which is going to be subtracting 11. So 3 minus 11 gives me -8 equals 4a, and this 11 minus 11 cancels. And then if I'm going to solve this for a, I have to do the inverse of multiplying by 4. So I'm going to divide by 4 on each side of my equal sign. So when this divides, 4 divided by 4 is just 1. And so I'm just left with a equals, and then -8 divided by 4 is -2. So what I'm going to do now is I'm going to, what I was looking for was a value to complete my vertex form of my quadratic function. So I'm going to take this -2 and I'm going to plug it in for this a right here. And this is a double check on yourself too, by the way. If you get a -2, that means your opening is down. So this clue told us that our a value had to be negative, which we found in -a, so that went ahead and worked out. So let's go ahead and plug this in and write our finished equation in vertex form, which is f of x equals, plugging that -2 in for this a here, I get -2, and then the rest of it, I had already plugged in my h and k, so I'm just going to copy the rest of that. So that's x plus 2 squared plus 11. Alright, so now I have my quadratic function in vertex form, and if I wanted to double check this against my given information, all I would have to do is, there's Bell. All I would have to do is graph it just to verify that the vertex was at -2, 11. The point in the table or on the graph went through 0, 3, and the opening was down. So that's how you would go ahead and check your work. Alright, so that's how you find a quadratic function in vertex form given that information.